This is 4.2.3. It tells us we have a certain machine and the time between breakdowns is an exponential distribution with lambda equals 0.2. Part A says what is the expected time between machine breakdowns? Okay, so just flat out, what is the expected time? So expected value for an exponential distribution is 1 over lambda. So 1 over 0.2, which gives me 5. So we'd expect about 5 days in between each breakdown. Next, it says find the standard deviation. Well, standard deviation for an exponential distribution is also 1 over lambda. Okay. If you're not sure, in our textbook we wrote the standard, or the variance, is 1 over lambda squared. So standard deviation is you just take the square root of that and get 1 over lambda. So 1 over 0.2, which equals 5. So that's my standard deviation. For part C, what is the median time between machine breakdowns? So how would I find the median? Well, a median tells me where my data is split in half. So to find a median, you set your CDF equal to 0.5 because you want half of the area on the left, half of the area on the right, and the CDF is what tells you all of the area to the left. So we set the CDF equal to 0.5. Now for an exponential distribution, the CDF is equal to 1 minus e to the negative lambda times x. Okay, so we set the CDF equal to 0.5 and solve for x. So in our case, this will be 0.5 equals 1 minus e to the negative 0.2 times x. And we have to solve for x. So we minus 1 on both sides, so we get negative 0.5 equals negative e to the negative 0.2 x. Or 0.5 equals e to the negative 0.2 x. And to get rid of the e, we take the natural log of both sides. So the natural log of 0.5 equals negative 0.2x, and divide both sides by negative 0.2, so x is going to be equal to the natural log of 0.5 divided by negative 0.2, which gives me 3.4657. So half of the times will be less than 3.46 and half of the times will be greater than 3.46. So that's our median. Now for part D. Suppose after oh, no, wrong problem. What is the probability that after the machine is repaired, it lasts at least a week before failing again? So we're just looking for the probability that it lasts at least a week, so the x is at least 7. So to find the probability that x is greater than or equal to something, well, we don't have anything that does that. The CDF only gives us areas to the left. So we would have to use a complement rule. So the probability that x is greater than or equal to 7 would be 1 minus the probability that x is less than or equal to 7. Remember, for a continuous distribution, it doesn't matter if you have a less than or equal to, because there's no value assigned at each individual point because there's so many possible points. So we can't find the probability that's greater than or equal to, but we can find the probability that it's less than or equal to. So we'll do 1 minus the probability that's less than or equal to. Well, that probability that x is less than or equal to 7, that would just be my CDF at 7. So we need to plug 7 into the CDF. So this will be 1 minus, okay, let's go back up to our formula for our CDF. Here's our CDF again, 1 minus e to the negative lambda times x. So 1 minus e to the negative lambda, which lambda is 0.2. So the negative 0.2 times x, which is 7. Let's see, and putting this into my calculator, it all gives me 0.2466. So that's the probability that it lasts at least a week. And part E, if the machine has already performed for 6 days, find probability it lasts at least 2 more days. So it's saying, if you already know it's lasted 6 days, what's the probability that it lasts 2 more days? And usually we would have to do conditional probability. But remember, we have that memoryless property, which says for an exponential distribution, it doesn't actually matter how long it's already worked. It won't affect the probability of it working for 2 more days. So the fact that it performs 6 days does not matter because of that memoryless property. It'll actually be exactly the same as if it had performed 4 days already or 8 days. It does not matter at all for this distribution. So all we have to do is find the probability that it lasts at least 2 more days. And that's going to be exactly the same as what we did in part D. So the probability that x lasts at least 2 days, we can't find the probability to the right, so we'll do 1 minus the probability that x is less than or equal to 2, because that is just going to be the CDF. So now we just have to plug 2 into our CDF. So it'll be 1 minus, again, 1 minus e to the negative 0.2 times 2, which gives me 0.6703. So 67% chance it will last at least 2 more days.